name is Jay Brunner. I'm an entomologist at Washington State University and director at the Tree Fruit Research and Extension Center in Wenatchee. I started my career with Washington State University actually as a graduate student, and I got my master's and PhD at Washington State. I've been working actually in Wenatchee on my research there on insect pests of pear. And that was a great opportunity. My interest in entomology really came out of an interest in basic biology, and then a desire to work in a field of biology that was interfacing with agriculture, which is I kind of grew up in a farming situation in Eastern Oregon. Throughout my career, I've had a lot of interest in working on insect behavior and using chemical ecology or chemicals that disrupt or attract insects, both for monitoring insect populations and then also for disrupting the behavior of insects for control. And so we're using pheromones, and we call it mating disruption. And starting in 1991, when the first commercial product became available for the mating disruption of codling moth, at that time the growers really understood that this technology could work. And since about 2000, after that area-wide management project, the industry is continuing to adopt mating disruption as a foundation for insect pest management programs. I've also had an opportunity to work with several graduate students, training graduate students, and that's a kind of a legacy. It's been enjoyable to see those students mature, graduate, and then move on and have careers in academia or research, private industry. So that's one of the fun parts of this job, is to invest in younger people and see them being successful in their own careers. Yeah, the impact of the research that we've done on pheromones is obviously significant, since it's been adopted by such a high proportion of the industry. The use of pheromones reduces the need for supplemental insecticide applications for codling moth control, which make up about 50% of all the insecticide applications on apple. So by reducing that significantly, it reduces the cost to the grower, and it also provides the opportunity actually to enhance biological control in orchards, because you're putting fewer pesticides in the system. Yeah, moving ahead, I think there'll still be a big emphasis on trying to stabilize biological control in orchards. It's a continuing process. Integrated pest management is a long view philosophy of managing pests in orchard. One area that I have a graduate student working on currently is searching for insect resistance in apple, certain apple genotypes that once discovered could then possibly be used in the apple breeding program, so that you have an apple that's good eating and good for marketing, but also doesn't require as many pesticides for controlling key insects like codling moth or leaf rollers. We continually have new insect or disease pests introduced from foreign countries. And right now we're dealing with two in Washington State. One is a spotted winged Drosophila. It's primarily impacting cherries, but since 2010, when it was discovered in the state, it has changed completely the cherry pest control program. And they were also dealing with another new invasive pest. It's a stink bug. It was introduced from Asia into Pennsylvania, spread throughout the eastern United States, and in the mid-2000s was found in Oregon. Now it's in Washington State. So I've had a great career at Washington State University. The benefit of being at a branch research and extension center is that we're intimately involved with the industry. We have close ties with the industry. And the tree fruit industry of Washington is a very progressive, very curious, very innovative, and a little bit demanding with high expectations of results. But those are all good parameters that come together to form an environment where you can always try out new things.